Modern software development goes beyond just writing code. It's about transitioning from a programmer to a software engineer. In this video, we will explore how to master essential skills for a successful career in software engineering. First, let's outline what we will cover. We will discuss the journey from programmer to engineer, focusing on the importance of communication and professional development. We will explore the software development lifecycle, from vision and requirements to maintenance. Finally, we will see how real-world practices come into play. Let's get started. The evolution of software development emphasizes the need for teamwork and meeting customer requirements. Dependability, security, and maintainability are key pillars of software engineering. While programming is important, it's just one part of the bigger picture. Communication is critical in software engineering. Understanding requirements, reporting bugs, and updating progress are vital. Engineers also communicate through code reviews, pair programming, and client presentations. Strong communication skills ensure success in projects. The Software Development Lifecycle, or SDLC, provides a structured framework for creating software. It includes pre-development tasks like vision establishment and requirements gathering. Development involves design, implementation, and integration. Post-development ensures testing, validation, and maintenance. Vision establishment sets the stage for success. It involves defining project goals, identifying target audiences, and outlining constraints. Key elements include problem statements, proposed solutions, and stakeholder benefits. Requirements engineering is another vital step. Requirements fall into categories like functional, non-functional, user, system, and domain. The process involves elicitation, analysis, specification, validation, and management. These ensure a clear understanding of what the software must achieve. Architectural design focuses on system structure and component relationships. Tools like UML diagrams and data flow diagrams guide this process. Clear system interfaces and design patterns improve scalability and maintainability. User experience design enhances usability and satisfaction. Through research, mockups, and usability testing, US design ensures the software is intuitive. Deliverables like wireframes and prototypes make concepts tangible and testable. Implementation best practices help create clean, maintainable code. For instance, you might see a code snippet showcasing a user registration service. This example demonstrates proper validation and modular design to ensure reliability. Integration strategies bring everything together. Methods like continuous integration and automated builds ensure smooth collaboration. Regular testing and documentation prevent issues during the integration phase. Testing is an essential part of quality assurance. Unit integration, system, and acceptance testing each serve a specific purpose. Practices like test-driven development and automated testing ensure robust and reliable software. Validation and verification ensure the product meets expectations. Validation focuses on user satisfaction and business value, while verification ensures technical correctness through reviews and testing. Evolution and maintenance address the changing needs of software. Maintenance includes fixing bugs, adding features, and optimizing performance. Evolution strategies like refactoring and managing technical debt keep the software relevant over time. Finally, let's summarize the key takeaways. The software development life cycle is a structured framework with specific goals for each phase. Communication, testing, and validation are essential to ensuring quality. Maintenance and evolution are ongoing processes that keep software effective. Thanks for watching. If you enjoyed this video, please like, share, and subscribe for more content on software engineering and technology. See you next time.